All right, this is where we left off last time. We talked about the trig component to arc functions, or inverse trig functions. We talked about creating triangles and simplifying and things like that. And then today we're going to finish up this section, and we're going to actually take a look at some derivatives. And this is going to be a series of derivatives that will help us when we get to antiderivatives as well. So these are our inverse trig functions, and we're going to write down each of these arc trig functions. And these are actually on your derivative sheet as well. So if you have that derivatives and antiderivatives, two different sheets that I printed out, that derivative sheet, these are, I don't know, like 20 through 25 or something like that on that sheet. At the very bottom, yes. And so these you can have on your test, right? Because you can have these two sheets, front and back, to use on your test. You don't have to do them from memory. So I don't expect that you have to memorize these. All right, so this one right here, its derivative is 1 over the square root of 1 minus x squared. For arc cosine, its derivative, it looks very similar, in fact almost identical. The only difference is that it's the negative of what we just wrote down. So that's nice, right? Tangent is 1 over 1 plus x squared. There's no square roots and it's addition. Cotangent, arc cotangent, is just like tangent, but it's got a negative on the outside. That was thunder, you betcha. Secant and cosecant, they are inverse derivatives, or derivatives of the inverse functions, are a bit more interesting than the ones we've written down so far. They just have a little bit more to them. They look very similar to what we had for sine and cosine. They've got a square root in them. But before we get to the square root, they actually have absolute value of x in the denominator. And then they have the square root. And then we flip around the subtraction. So instead of 1 minus x squared, it's x squared minus 1. Same thing on the second one, except what do you suppose? Sine and cosine were the same except for what? The negative. Tangent and cotangent were the same except for what? The negative. So what do you think about secant and cosecant? Yeah, the next one, cosecant's got a negative. Looks exactly the same except for with a negative out front. Yep, absolute value of x.
1 times 1?
Absolute value. And then we're going to do some examples, because that's what we do in math, right? We do examples. So here's the first one we're going to do. So arcsine of t squared. All right, so arcsine means that I've got a square root in the denominator and it's 1 minus x squared. And that's what we just looked at there, right? So again, I think, Emily, you've asked me before, can I leave these t's in here or can I remove them and turn them into x's? If you want to turn them into x's, you certainly could. I'm going to leave the t's in there because I think my t's are distinguishable enough. It's a prior right. All right, so this is arcsine, which means I have 1 over the square root of 1 minus something. But what will it be 1 minus? T what?
T to the 4th.
T to the 4th. Why t to the 4th, Dylan?
Because the x is already squared, or the function is already squared. So.
Right, this rule over here has x squared in it with the plain old x in the function, right? So right here where I've got my t to the 4th, that's actually t squared squared, right? It's whatever's inside the trig function, and then I square it. But this is an inside function. I used the word even already, didn't I? So this is that chain rule stuff going on, which means I need a derivative out here of t squared, which is 2t. So there's really not a lot of simplifying I have to do. The only thing I have to do, in fact, is to put the 2t on top. which you could have done while you were doing the problem itself if you'd wanted to, of course. And we mentioned this last time, and I'll mention it again here. We can definitely have the square root in this denominator, because depending on what t is would depend on whether or not I was allowed to leave it there. Okay, so there's nothing wrong with the square root here being here. But this one, it's got some natural log stuff in it, so that starts to look like the gateways or the derivative basic skills test you did. It's also got an arctangent in it, so that's good because we just discovered all these arctangent and other sign kind of arcsine and whatnot derivative rules. So I've got a natural log. How do I do the derivative of a natural log? What do I do? Good. And then what, Hannah? Right, times the inside, which is 2t. And I've got the minus 1/2 because it is a coefficient. Now I've got arctangent. So if you flip back to arctangent on your papers, or if you look over on your other sheet, arctangent is what? What is its derivative? They're all pretty much 1 over or negative 1 over.
1 over 1 plus x squared.
And this problem has t's in it, so I'm going to do t squared. But is it just t squared here? It's t over 2.
T squared over 4.
Right, so I'm going to write it as t over 2 squared, but of course we are going to make it t squared over 4 in a moment. All right, so let's combine what we can. So this is 2t over t squared plus 4 minus, and right now I've got 1 over, and I've got a 2 down here, which I'll distribute in a moment, and then I've got 1 plus t squared, and like Cameron said, that's over 4. When I distribute the 2 through, it's going to change it a little bit, but it still isn't going to quite match the other one yet. And of course, you heard the word yet, didn't you? So this one would become 2 plus t squared over 2 now, right? And I'm just 100% sure, not even a shadow of a doubt, that nobody ever in your math career has let you leave that t squared over 4. Well, maybe on that basic skills test I would have, I guess, but not right now. Oh, and I shouldn't have said 4, I should have said 2, because I distributed by 2, I'm sorry. We're not going to leave a t squared over 2 either. So what are we going to do so that it won't have that 2 in the denominator as another denominator?
Can multiply by its inverse.
So what would you like to multiply by, Dylan?
2 over t squared.
Easier than that. Times it by 2. Now, I'm going to multiply the denominator here by 2, but you can't just go multiplying a denominator by 2. That's certainly not an allowable operation. What do you have to do as well? Yeah. So if I do this to the denominator down here, I'm going to multiply by the numerator by that as well. So now I have 2t over t squared plus 4 minus 2 over what? Not 2t squared.
Oh,
T squared, right? This is distributed across here, and that's the reason I wanted to multiply by 2 to begin with, is so that I eliminated the denominator of 2. So that's t squared. And then what do you notice about my two denominators? They are the same. Isn't that so wonderful? So I can combine them, and my whole expression would be t squared minus 2 over t squared plus 4, or 4 plus t squared, it doesn't matter. You had no idea when we started the problem that it was going to combine so cleanly, did you? You just never know. All right, we got one more. We've got an arcsine function, and we've got a just beautiful fraction after that. It's just wonderful. So let's start with the arcsine part, okay? So we're going to take a derivative. So I'm going to rewrite my 8. How do I do arcsine? What's its derivative? I'll start out. It's 1 over something. It would be 1 minus x squared if it were just arcsine. So instead of x squared, you got it. So this will be x over 4, and all of that squared. So that's the first portion's derivative. We have our subtraction sign. And now what's going on over here with this x squared, 16 minus x squared over 2? If I were doing an antiderivative, I'd be very happy because I could use u substitution, but this isn't an antiderivative, right? So what kind of rule do you see happening here? We do have a chain because we've got something underneath the square root. What else? It's a product, yeah. Do we have a quotient rule here? No, because what's my denominator? It's just 2. So couldn't I just write that as a 1/2 in front and not have the whole fraction thing looking like thing going on here? Yeah. And that's what I'm going to do. I'm going to treat this very much like this said, 1/2 x and then square root of 16 minus x squared. Okay? So I'm going to start with the 1/2 x part. So do you want to write it down or do you want to take a derivative first? Oh, let's take a derivative. I think all of you are doing it in that order. So let's do the derivative, 1/2. And then I would write down the square root 16 minus x squared. And I've got addition. Notice I started this out with a bracket at the beginning. Did you notice that? Because I want to make sure that in a moment here that the negative that's on the outside of here is going to distribute through. Now I need to write down the 1/2 x. And what's the derivative of square root 16 minus x squared? Why do we want to bring in cube roots?
Stay squared. 1 over.
Remember, we can think about this instead of the square root as a power 1/2.
So when you subtract 1, it's
Oh.
going to be.
Well, first let me pull the 1/2 down. Okay? So let's pull that 1/2 down. And then I need to write the 16 minus x squared to what new power? Negative 1/2. It's 1/2 minus 1. So there's no cubes that come involved. 1/2 minus 1, I will get a negative 1/2. A negative 1/2 would be the same thing as having a square root in the denominator, right? Negative goes to the denominator. So I'm going to extend this and put my square root in the denominator. And I'm out of space to write it beside it, so I'll write it actually on top in a moment. I still need the derivative of the inside function, which would be what here? Negative 2x. So I'm going to put it on top. All right. Got a lot of simplifying to do, I think. Let's start at the beginning here. You might notice the 16 minus x squareds are in 2 of the terms in the second piece that I just did. The first one has something else, but it looks sort of like what I want. But it's got a fraction in the denominator. I mean, I've got a square root there. So we're going to have to deal with that in a moment. I'm going to not deal with that right away, but let's just write this portion for now. So this is 1 minus what, if I simplify that? And there's that mysterious 16 that I've got going on the other pieces, right? That's a very good thing for us. This is 1/2 square root 16 minus x squared plus, now this 2, not the negative portion of it, but the 2 part cancels with one of the 2's in the denominator. I don't care which one. And it won't cancel the x because that other x is in the denominator. But it will become x squared, right? It'll combine with it. So I've got x squared, I've still got a 2 in the denominator, and I've got a square root of 16 minus x squared in the denominator.
And you can fix the first one.
Okay, tell me how to fix the first one, Cameron. What are you seeing?
Times by 1, but it would be a 4 over, when at top you get 4 and the bottom you get 16 inside.
All right, so I'm going to multiply by 4 on top, and in essence, square root 16, which is the same thing as 4, right, on bottom. The reason I want the square root 16 is because if they're both in square roots, one of the properties of square roots is that I can combine them if it's multiplied like this. You can't do that with addition, but you can combine it with multiplication. So this square root of 16 will turn this into a 16, and this one will be turning into an x squared. And then it will look exactly like the other one, so won't it? Yeah. So, and then I end up with a 32, I think, on top here. So I have 32 now over 16 minus x squared. Okay, I'm actually going to rewrite this middle one so that the 2's in the denominator, just because I'm going to have to get common denominators here in a minute anyway. So I'm going to write it as though it has a legitimate numerator and denominator. And of course the second one, or the third one rather, it stays the same. So what will my common denominator be?
What the last one is.
Yeah, it's the last one, isn't it? I have a 2 because it's in there a couple times, and I've got the square root 16 minus x squared. So the first fraction, 32 over the square root 16 minus x squared, what will it be multiplied by? 2 over 2. How about the middle one? What will it be multiplied by?
The square root.
Which is actually really nice, because what happens when I multiply those 2 square roots on top?
Just becomes 16 minus x.
It will. It'll just become 16 minus x squared. Even after I said it, I lost it along the way. This is a negative, isn't it? That negative distributes through here. Sorry, let me get my signs right. Okay, so Cameron told me that middle term does something very friendly. So 64 on the top. I have minus, and I'm going to put parentheses around it, 16 minus x squared in the middle term. And then what on the last term is just x squared, right? And this is all over 2 square root 16 minus x squared.
I know the bike today. Well, I don't know far.
Okay, Nidra, what's your question? Which negative? From the negative 2x? Oh. Well, we ignored it, but we shouldn't have. You're right. Nidra's asking me what happened to, let me use a different color. This negative. And I think that should have been combined to actually turn this into a positive. So I almost made 2 mistakes that would have canceled each other out. Who was it in my office that I was talking to about that the other day? Was it you, Emily?
You carried it down.
No, because I have a negative out in the front as well.
Oh, okay.
Yeah, so I actually overlooked both of them. Yeah. Okay, let's see what we've got to clean this thing up. So I'm out of space on the colorful sheet, but it's okay. So
2x squared.
So let's do this. Let's see, I've got 64 minus 16, right? So what is 64 minus 16? No one knows.
48?
I think it's 48. That's what I did in my head, too. 48. It's okay. And then I actually have, let's see, did I lose it again? Oh, I did. So this is actually a plus now. Carry it all the way, right? So I've got this negative and this negative making that 2x, this x squared, and this one's x squared. So I've got 2x squared.
Can we just take out the 2?
We definitely are going to do that. And then I had 16 minus x squared. Because every term is actually even, I can take out a 2, like Cameron said, factor it out, cancel it out, however you think about it. I'm going to end up with 24 plus x squared over the square root of 16 minus x squared. Provided that we didn't make any other errors. No, because depending again on what x squared is, it could be actually already in rational form. So anytime you've got a variable underneath a radical, you can leave the denominator in radical form. Any questions on that one?
That was a mess.
It was a mess. And we made it through, didn't we?